we want to do the question number 15. A mixture that is a camphor, and then the benzoic acid can be separated by the process called as a chemical method, sublimation, fractional distillation, and extraction with a salt. Actually, camphor is a best example for a sublimate because it is directly converted from the phase of the solid state into its vaporous state just by the application of which one? Heat. Even also, benzoic acid and salicylic acid are best examples for the sublimates also. If both are the sublimates, we can't separate by the process called as sublimation. If one is sublimate compound, then we can separate with the rest of the organic compounds or any of the impurities that has been present. But here, it has been separated by what method? It is the chemical method. Why this? Because camphor and benzoic acid, as it is a carboxylic acid, it readily gives a brisk effervescence of sodium bicarbonate in the form of sodium benzoate, along with the liberation of carbon dioxide and then the water. This is acidified with Hexer or H2SO4 to recover the pure water acid. Means it is not the physical method of separation, it is only the chemical. If sodium bicarbonate doesn't have a reaction with respect to which one? Camphor. Therefore, the camphor and the benzoic acid, both being the what? Sublimates, they can be separated by what method? It is a chemical method. Okay? The IUPAC name of acetyl salicylic acid is, what is the IUPAC name of the compound called as acetyl salicylic acid? This is first called as benzoic acid. Orgo-hydroxy benzoic acid is called as salicylic acid. But here it is acetyl salicylic acid. This is H has been replaced by acetyl group, therefore it is called as what acid? Acetyl salicylic acid. Here, this is found to be the what? Carboxylic acid is the main, it is the ester, and this is the what? Carboxylic acid. This is the major functional group, and this is found to be the substituent. So here, first it is called as benzoic acid is the main thing. Benzoic acid. This group is called as acetyl. Acetyl toxin is called as what? Oxide. Acetoxin. And it is present in the position called as which one? 2. Therefore, it is called as 2-acetoxin what acid? Benzoic acid. Our common name is for that one is orgo-acetoxin. This one. Or it is simply called as commercially sold in the form of an antipyretic or anti analgesic drug in the form of which one? Aspirin. Aspirin is chemically called as acetyl salicylic acid, and its IUPAC is found to be the 2-acetoxy what acid? Benzoic acid, or sometimes in the common system also it is mentioned as orgo-acetoxy what acid? Benzoic acid. Therefore, it is 2-acetoxy. What is the IUPAC name of that particular compound that has been taken? What is the IUPAC name of that compound? So here, CH3 one is, another is at the base we are having the CH, right? Then CH2, CH3, and N is attached to CH3 as well as CH3. So what is the IUPAC name for this? First, select the root. Leave this 3, but here it becomes 4. 4 means built. Sorry, not 4, it is 5. 1, 2, 3, 4, 5. It is pentane. Saturated means it is 8. So pentane. Okay. Next, what is the function? Here it is amine. Here from this also it is the third position. From this also it is the third position. Therefore, it is called as pentane. How much amine? 3 amine is mixed. Then what are the substituents here? This is methyl attached at third carbon. Therefore, it is first called as 3-watyl methyl. In addition to that, these are also the substituent, but they are not attached to the pairing chain, but they are attached to the nitrogen atom of amine. Therefore, in bracket you have to mention again this 3. What comma what? NN. What methyl? Dimethyl. Pentane. NN dimethyl. So first it is 3-methyl. NN dimethyl. Which one? The root word is spent and the amine is present at which carbon atom? Third carbon atom. Therefore, it is the 55th degree. Next, which carbon atom is the most electronegative in the structure? Which compound is going to be the most electronegative in that particular? 1, 2, 3. Whether all or any one is the most electronegative structure. Carbon with higher percentage of S character has higher electronegativity and having highest of the acidic hydrogen. Anything which has been attached to water. A percentage of the carbon having the highest S character. Highest S character, we know that Sp is having greater than, Sp2 is greater than Sp3 because it is 50-50. Here it is. The percentage of this one is going to be the 33 something. Here it is going to be the 20. Therefore, the percentage of highest S character is in case of Sp. If it is be the case, it is having the highest what nature? Electronegative nature. If highest electronegative nature means the respective hydrogen is going to be what acidic? More acidic. Therefore, this is I think Sp3 I think. This is also Sp3. This is Sp and this is Sp. Therefore, which hydrogen it is? Here it is not mentioned here. It is only the 56 RE. Next is what is the IUPAC name of the following compound? Just I will that I will write now. 57. What's IUPAC name of this compound? So here it's very clear. Cyclohexene. If I start the number from here, it becomes not out 2, but we are leaving this. If I start from here, don't start from here because 1, 2, 3, 4, 5th position is the meter. Therefore, if this be the case, it is 2 and here it is 3, here it is 4, here it is 5 and here it is 6. Therefore, what should be the name of that? It is hexene, not out. What hexene? It is cyclohexene. But where the meter group is at? Therefore, it is called as 3-methyl cyclohexene. Next is, what is the IUPAC in the following compound again? H, OOC, CH2, CH, CH2, CH2, COH. Again, we are having another COH. So they are having a similar function, preferably they are the terminal function. If 2 be the case, if it is at the first and last, we can include that in the what word? Root. Suppose, if these 2 bits included, this can be away from that. Therefore, don't try for that one. We have to take this as a what word? Root word. What's the root word there? 1, 2, 3, 4. 4 means it is butane, saturated AMA. Therefore, it is called as butane. Then what are the function groups here? 3 carboxylic acid. Now you are going to separate the suffix. That is called as carboxylic acid. Not the oic acid, not the carboxy. Oic acid is only one, if that be the case, the main function group. Followed by, if it is a substituent, it is acting as a carboxy. But here, all are the same function group, all are the major function group, but we can't include all 3 in the same parent chain. Therefore, on that basis, it becomes a carboxylic acid. They are at the positions. For example, if this is 1, here it is 2, here it is 3, here it is 4. 1, 3, 3. From this it is 1, 2, 1, 1, 2. And this is not correct. Therefore, 1, 1, 2 means what butane? Butane 1, 2, 1, 2, 4. 1, 2, 4. What acids? Tricarboxylic acid. Butane 1, 2, 4. Tricarboxylic acid is the IUPAC name of that particular compound. Okay. The compound the form in the positive test for the nitrogen in the Lassen's solution of an organic compound is, I mentioned all the organic compounds that have the name of the compound that has been done during the last test using the help of sodium fusion extract. So here it is nitrogen means we are mentioning that as Prussian blue. What the Prussian blue is called as ferric ferrocyanide. What's that? Ferric ferrocyanide. So here it is. So this is in case of which one? Sulfur. This is in case of both the carbon, nitrogen, and then the carbon and nitrogen along with only nitrogen. So not nitrogen here. It is not the ferric ferrocyanide in the case. It is carbon, nitrogen, and sulfur. But here ferric ferrocyanide is Fe4, Fe, Cn6 with what? 3. This is called as either the Prussian blue commercial name or it is having the IUPAC name of ferric ferrocyanide. Okay. Lessons test for the detection of nitrogen phase. Why? In case of which compound? I have already mentioned sodium with the carbon nitrogen present in the organic compound gives rise to NaCN. It is called as SFE. Then we are adding the different reagents to form Fe4, Fe, Cn6 with X. As there is a failing of the nitrogen test in the compounds, means for cyanide we should have the combination of both which and which? Carbon and nitrogen. If nitrogen is present, it is not correct. It is carbon along with nitrogen given in the formation of which one? Cyanide. So here it is a nitrogen, here it is this. So I think there is no only the hydrogen but not this. Therefore, this is the correct. Therefore, carbon and nitrogen. This is also possible. Carbon and nitrogen. Therefore, the option is correct. As I mentioned, it is an inorganic compound. It is not an organic. This is called hydrogen chloride. NH2 NH2 is called as what? Hydrogen with the acid component. That is called as salt. Actually, it is not hydrogen chloride. Okay. The compound is known by which of the following name? The compound is known by which of the following name? So let us draw the structure for that. T1. Okay. It's actually a bicycle compound. So here I can choose this as this or this as this. This is the first carbon atom or this may be the first carbon. Let us check that. If this be the case, here it is 1. If this be the case, here it is 2. This be the case, here it is 2. Therefore, we have to swap this. On that basis, so this is equivalent to this. Because at the bridging, we should have the minimum carbon atoms. Here the bridging is actually 2 carbon atoms. The same if I swap like this, now it becomes only 1 carbon atom. Now, 1, here it is 2, here it is 2. 1, 2, 3, 4, 5, 6, and then here it is 7. Total how many carbon atoms we are having? 7. 7 refers to what? Heptane. Heptane with how many cycles are there? 2 cycles. Therefore, it is called as bicyclo. Towards left we are having the 2 carbon atoms. Towards right also we are having the 2 carbon atoms. At the center we are having the 1. Therefore, it is called as bicyclo 2, 2, 1 in the form of which one? So, converting, we should have the minimum number of carbon atoms at the center of the bridging carbon atoms. As it is having only 1 towards the left and at the center we are having the 2. Just we are interchanging that to get the minimum carbon atom at the bridging center. That is why we are expecting the bicyclo 2, 2, 1 in the form of which one? Okay. Now, in an experiment, 0.22 grams of magnesium pyrophosphate was produced from 0.1 grams of an organic compound. Therefore, the percentage of phosphorus in that particular compound is how much? So here, we say here phosphorus. What the phosphorus in the organic compound is converted as? Mg2P2O7, magnesium pyrophosphate. Magnesium pyrophosphate. The mass of the organic compound that we have taken is 0.1 grams and the mass of the magnesium pyrophosphate that has been formed is 0.22 grams. How do you get the percentage of phosphorus? 100 ZX by MW. 100 into what is that? Atomic mass of phosphorus. is mass of the elemental compound. Elemental compound is magnesium pyrophosphate, that is equal to 0.22 divided by. What's actually the molecular mass of Mg2P2 as well? This is 24 and this is 31. This is 16. If I simplify that, it is going to be the 222. What is 222? It's a molar mass of magnesium pyro, which one? Phosphate. W is mass of the organic. So here it is actually 22. So this is also 22. 22 can cancel. 31 2s are this. Here is 60. Then you see. 61.44 is the percentage with respect to which one? The phosphorus present in the given organic sample or with a so now 63. So I have to write the structures for that. Okay, what the structures are? Now, in the first case, HCl, and this is ClH. And in the second case, HCl, HCl. So here, we have to know the R and S configuration first. Okay? First, I am deleting the A and D. Why? Note they are isomers. 1 and 2 are not enantiomers. Why? Because enantiomers means they must have the what? Mirror images. And those mirror images must be non-superimposable with each other. First of all, they are not the examples with respect to which one? Mirror image. Therefore, I am deleting the what? D. 1 and 2 are anomers. What are anomers? They are the pair of optical isomers having the change in configuration only at the first chiral center. This is the first chiral center, this is the first chiral center. There is no change in configuration. Therefore, this is all. Now I left with what and what? B and C. It is based on S, R and S notation. So as this is the carbon, let's mention that as. So here it is. C. Here it is also C. Here it is also C. Let us call this as C2. This is C. This is called C2 and this is called as C. Both are chiral centers now. Assuming this in the first place. So here, the priority with respect to that one is, this is chlorine, this is carbon CH3, this is hydrogen and this is CH3, it's CH3. Therefore, the preference is chlorine first, this is second. Why it is? Because CH3 is CH3, but here it is only CH3. Then here it is, and this is. We know that according to the rules of Prelogson, CIP, con inward and then Prelogson, during the configuration, in predicting whether it is a R and with a yes, the smallest or the least priority must be at the base. Must be at the base. But here, this is the least priority, this must be below. Therefore, interchange these two. Interchange these two. Such that I am getting, on interchanging I am writing only C2, let us take. I will get this as this. And the total, this I will mention in the form of X, for example. Right? Only for this time. I will mention that as X. This is the third one. Okay? So the second. Now, similarly, you have to rechange or interchange these two. Therefore, this becomes Cl and this becomes what? CH. This is at the first priority, this is at the second priority, this is the third priority. Move from 1 to 2, 2 to 3, either the clockwise or it will be anti-clockwise. 1 to 2, 2 to 3, therefore, it is in the anti-clockwise, therefore, 1 is means and the second carbon atom it is 2 is first. Immediately I will give the answer here. Okay? because it is 2s. Let's try for the third carbon. If I try for the third carbon atom, so let us mention C3 now. So now this we will mention in the form of X right now. X C3. This is Cl, this is H, and then this is C2H5. C2H5. Now this is this is first priority. X is totally this carbon with Cl and then Cl. Therefore, this is having the dominant 2, and here is having 3, and there is 4. But you know that it has to be interchanged such that H and C2H5 is reversed, and X and C, here is Cl and here is X. Cl and then X. Again, I am mentioning the same. Sorry, it is X. Here is Cl. Means interchange these two and interchange these two. Therefore, X here. Here, first is this one. X is this. Therefore, this is the second, and here this is the. What is this? Again, it is anti-clockwise. Therefore, this is also what? Yes. Means 1s and 3s. And in that case, it is 2s and 3s. So that you will work out. Okay? As if I mentioned only the one is we have proved that it is 2s and 3s. They are in the anti-clockwise, that is when these both are s. Let us have a try on your own to prove that second carbon atom is 2s and the third carbon atom is what? Okay, so if considering this C2, it is not at the base. H is the least priority. Come to this side, therefore exchange these two and exchange these two and observe whether it is a clockwise or anti-clockwise. Similarly, consider the third carbon atom, interchange these two and interchange those two. If hydrogen comes at this and observe whether it is in the C1, C2, C3 or 1, 2, 3, they are in the clockwise or anti-clockwise to prove that whether it is an S or it may be the carbon operation. Okay, so that I am not actually done. You have to try with the second compound of the sample. Okay. Next, enol content is highest in where the enol content is highest, as I've already mentioned. If active methylene group is present at are present between two CO groups, it is found to be the more acidic. Then we will have the more stability, and that is more stability is due to the intramolecular hydrogen bonding and then the resonance. Means any carbonyl compounds where the active methylene group is. What the active methylene group is? The methylene group which is adjacent to electron withdrawing two methylene groups, that becomes the highest. Because in general, the keto always having the highest compared to that of enol, but with the exception of alpha hydrogens. So here, that is the best example that we discussed in the form of acetyl acetal. How it is? CS3CO, CH2CO, CH2. This is called as acetyl acetal. AA we often get. It gets shifted here. H. This gets a minus and this gets a plus. Double bonds is formed here. H is equal to bonds. Therefore, CH3, C double bond O, single bond CH, double bond C, single bond O with what? H, single bond CH. This is actually the keto form, and this is the enol form. And this is called as what bonding? Intramolecular hydrogen bonding. Intramolecular hydrogen bonding, it requires the presence of which one? Conjugated pi system. Conjugated pi system means it is called as resonance. Due to the not only the resonance effect but also the presence of what? Intramolecular hydrogen bonding. Which form is stabler? The enol form is stabler, that is having the highest character compared to the top which one? The key. Okay. Next, in the estimation of nitrogen by what method? Dumas method. 1.18 grams per organic sample of the compound gives 224 ml of nitrogen NP. Therefore, what is the percentage of nitrogen in that particular organic compound? So here percentage of nitrogen according to the Dumas method is given by 28 P0 divided by 224 into W. What is B0 actually? It is the volume of nitrogen that has been obtained at the condition of STP or it may be the and W is as usual the mass of each compound organic. So that's equal to 28. As it is NTP means the volume is going to be the 220 divided by 220. It was the mass of the organic sample that we have taken here. It is going to be 1.1. 28 divided by how much? 1.1. So what happens when I simplify that? Here it is. Assume that it is nearly 1.2. It is mentioned as 280 divided by 12. 12 2s are. 12 2s are. Then I am left with 4. 4 means 40. 40 means 23 something. Suppose if this be the case, not this one. At a certain temperature and the pressure, suppose if this is given here, V is given as 224 M. Well, if NDP is not provided, or STP is not provided, other than that it is a laboratory temperature and laboratory pressure. Then it is not V0, it is actually the V. Now, to get to V0, we have to have the new formula that is T minus F into V into T0 divided by T0 into V1. Laboratory pressure, aqueous tension, volume of nitrogen at LTP. This is standard temperature that is 273 Kelvin. This is standard pressure that is 1 atmospheric pressure and T is called as the room temperature of the laboratory temperature. But as if NTP is already given, it is directly the what not. Okay. Let's move on to the last. The function of which one? The boiling. Function of boiling the sodium fusion extract or sodium extract with the dilute nitric acid before testing for halogenase, as I already mentioned. Halogen has to be detected by treating SFP with dilute Session-03 followed by, then we are to treat it with silver. Because as this organic compound containing, suppose if it is nitrogen at which one? As it is in the sodium fusion extract in the form of sodium cyanide or sodium sulfide. And this is to be converted by heating with this in the form of HCl or it may be the H2S. And these are found to be the we just show you the which are which. The cyanide in the form of hydrogen cyanide and sulfide in the form of hydrogen sulfide just to destroy the what? Cl minus and then H2 minus. Once if they get removed, we are having only with the X to form a respective precipitate. Silver, maybe in the form of silver chloride or silver oxide or silver, added of certified precipitate or pale yellow precipitate or the bright yellow precipitate. But here, before adding the which one? Silver nitrate, we are adding or we are boiling which one? Dilute nitric acid just to clear out to destroy the cyanide as well as the water ions. Okay, so I think this may complete the some of the biggest or one of the biggest topic with respect to organic, that is called as some basic principles and techniques involved in the organic chemistry. Okay, so it is the most important topic with respect to the organic because the whole of the first and the second piece is mainly decided by the concept present in this particular chapter. Okay, so I have provided some of the assignment questions to the belonging to this topic. You can have the go through that and you can have the solving of the rest of the questions. Nearly 75 to 80 are given. So make a clear key answers for that and also make clear solutions with a hint points, because as if the time is very sensitive with respect to our sense, time is very essential during the solving of the competitive questions. Therefore, you have to use some of the tricks or the hints that has been given in the various synopsis that